So in previous class, we have learned about the processor logic design and the processor organization, how it is being done. We have seen we have discussed about the bus organizations and a little bit of ScratchPad memory. We can just go through the ScratchPad memory. Like what is ScratchPad memory? It will be a small memory when compared to that of the main memory, and it will be included within the processor. So this memory will be called as the ScratchPad memory. So when you see the diagram, you will be able to see this. This is a ScratchPad memory, and this is placed within the processor. Using this ScratchPad memory, to this ScratchPad memory, you will be able to take the data and place it on to the registers A and B. We can perform read and write operations. So in order to perform any read as well as write operations, address need to be specified similar to the memory itself. So we need to identify the address. So this ScratchPad memory will be of a fixed size, like it will be allowed to store some 8 words, like that it will be. So these words will be stored in some locations, and if the one word size is 16 bits, means the memory can be like a 8 into 16. So address is required to identify the location where the data need to be taken, or the data need to be written into the ScratchPad memory. So for that, it will be making use of some address bits based on the size of the word that is being stored inside the or allotted to the ScratchPad memory based on the processor. Then what you can see over here is when we discussed in the previous class how the data was taken from the how the input data was fed to the arithmetic logic unit with the help of the multiplexer. Multiplexer was selecting from some set of registers which will be placed on A bus and B bus. 2 registers will be placed, and it is action will be performed by the arithmetic logic unit. Similarly, here what it does is, here we are having ALU to perform the operation. 2 registers are also there. 2 registers are there in order to give the input to the ALU. And here just see, from the ScratchPad memory, no separate bus is there to load the value for A and B. Okay, so from the ScratchPad memory, single bus will be used to share the information. Bus line will be used to share the information or load the information to the register A and B. It will be sharing it in a single line. And in order to identify the location where the output of the ALU need to be loaded, we make use of the multiplexer. Okay, so in previous case, in order to load the output to the registers, it made use of the decoder. And here, in order to store the output, that is ALU, it will be providing some output to the shifter. It will be performing some shift operations based on the instruction that is given. If not, no shift operation. Without the shift operation, it will be just passing the data to the bus, which will be given as an input to the multiplexer, which means that this multiplexer, it decides in taking the output data or the output information from the ALU or any input that is obtained from serial input. So this multiplexer, it will be choosing from some input data, from some serial input data, or the external, that is the internal output, operation output, whether it need to take these 2 inputs. It will be selecting from these 2 inputs to be placed on the ScratchPad memory. Okay, so if the output need to be written to the ScratchPad memory, means multiplexer, it will be selecting this output that is fed on the bus, or it will be taking the information that is currently available in the bus, and it will be checking the address lines, that in order to find the location, it will be checking the address lines in order to find the location where this output need to be stored. Okay, so in one more case is like from the ScratchPad memory directly it can be given to some other serial output. Okay, without performing any ALU operation from the ScratchPad memory, the data can be taken and can be used for some other purposes. That's why here it is given as output data. Okay, so this is the case of the ScratchPad memory. The ScratchPad memory can be treated as a main memory of the computer. What is the difference? This is a small memory which is located within the processor. A main memory will be like it is dedicated to store the instructions and data. Then here we can just see one more example, like here R1 is replaced with the addition of two registers R2 and R3. So here R1, R2, R3, they are the locations inside this ScratchPad memory. Okay, so let it be like R1, R2, R3. So as we have said earlier, we can identify their address like 001. Why I am giving 001 means here I am assuming that the ScratchPad memory is having some information, that is it will be having some 8 words. It is allowed to store some 8 words of 16 bits. So in order to identify these 8 words, 8 cells in identify ചെയ്യണമെങ്കിൽ എത്ര bits use ചെയ്യണം? 3 bits need to be used. Okay, അപ്പം R1 to R8 എന്ന് പറഞ്ഞിട്ട് ഉള്ള ഒരു ലൊക്കേഷൻ ആയിരിക്കും സ്ക്രാച്ച്പാഡ് മെമ്മറിയിൽ ഉണ്ടാവുന്നത്. So from there, in order to identify R1, address bits should be given as 001 and R2 means 010. So here addition operation of R2 plus R3. So what is the first control function that will be taken? Let us set E1 at any clock, any timing variable T1, M of 010. So that is first operand it is taken. First operand, what is the first operand? R2. R2, the address will be like it can be written as 010, isn't it? So memory means it need to be represented in this format. So R2 M of 010 will be loaded to register A. Okay, it will be taken as the first operand. So 010 will be loaded to register A. So load is being initiated over here. Okay, so a common line will be there connected to the registers A and B, and from this bus based on the initiation, that is in first that is a timing variable T1, load is initiated to the register A, which allows the register A to access the information currently available in the bus. And second timing variable, what happens? R3 will be loaded to register B. So R3 address can be written like 011. In order to represent that it is memory, M of 011 will be taken, which will be loaded to B. So what will be the action performed here? Load will be initiated to the register B, in which retrieves the information that is currently available in the bus. And then finally performs the addition operation. That is, now the data it is available in A and B. Perform the addition and store it to the memory location M of 001. Why here it is given as 001? Because here in this micro operation, or in this operation, it is given as R1. Left hand side is given as R1. So that's why here in this micro operation, we are specifying it as M of 001. So this helps in storing the result to the register R1. So here that with the help of shifter, the output will be finally available in the bus, and from the bus, multiplexer will be choosing the data from the bus instead of from the input data. From any other input line, it takes the information from the bus that is currently available, and with it, it passes to the ScratchPad memory, where it will be passing based on the address that is being mentioned. That is R1. It should be loaded to R1. So the address will be like 001. To that location, the result will be stored. So this is a usage of ScratchPad memory. So in your textbook, one more thing is given, like ScratchPad memory can be implemented using a two-port memory. Okay, so two-port memory means instead of multiplexer, without making use of any multiplexer, we will be able, one more additional bit will be placed over here, like WE, that is write enable, and here memory enable. So two connections, additional connections will be there. Just go through the textbook. Memory enable. Okay, so if write enable is initiated, then what happens is from the register A, memory will be from the register A. One second.